Hi guys, so today is the day 5 of this September LeetCoding challenge, and today we'll be solving this orderly queue problem. And in this problem, like, we have been given a string s, and we have been given a integer k, and we are like allowed to choose any character in the first k character and move that character to the back of this string. And we are allowed to do this kind of operation any number of times. So we need to return the lexicographically the smallest string that we can like obtain after applying this mentioned step any number of moves. So let us take an example. So here, like, this string is CBA and k is equal to 1. So we can do what? We can like first move the C to back of this string, then this it will become BAC, and then we can move this B also to the back of string, so it will become ACB. So this is the lexicographically smallest string that is possible with this move. And there is another example, and here, like, k is equal to 3, so this string is BAACA. So the answer is AABC, and like it is possible. Like, first we can do what? We can move this B to back of this string, and in the next step, like, we can take this C and move it to back of this string. So like in the next move, like, this C will become the third character, so we can take it because k is equal to 3. So the resultant string will be AABC. And now, like, let us take a look to the constraints. So the length of the string can be at most 1000 characters, and the k is also ranging from 1 to less than equal to n. And yeah, so like seeing the constraint, we can see that the an order n squared solution will be able to pass all the test cases. So actually this problem may look very complicated at first, but there is a let us analyze like what will happen if we will perform some k equal to 1 or k equal to 2 operations. So k equal to 1 operation can do what? It can take any string, any first character, and move it to back character. So basically doing this, we can start the string from any character. Like, we can make this string to look like BAC, we can make this string to look like ACB. So this order will be preserved in this case. Or we can like treat this string into of like kind of bead, and like a yeah, it can we can for like consider this string to be made of a chain of beads, and we can break this bead from any part to make this string resultant string. So like if we are only allowed if k is equal to 1, then what we can do, we can like consider all the n strings that we can form, and we can check for the lexicographically like a best string, a smallest string, and we can print the answer. So for like making the n strings, the time complexity will be order n, and like for checking whether that string is lexicographically smallest or not, the time complexity will be order n also. So it will be the order n squared step. So this k equal to 1 is like a case can be handled in order n squared. And let us suppose what will happen if k will be equal to 2. So like let me explain. So suppose we have got an array, yeah. So like I am using 1, 2, 3 these numbers instead of characters to represent like which character was at which place. So like this is the first character, second character, third character, and so on. Suppose like there are 8 characters, right? I'm just like considering a general case. There may be more than 8 characters also. So like if using k equals to 1 step, we can like take this element and move it to back, right? And so this will like preserve the sequence of the characters. And if we will be doing k equal to 2 step, so if we are choosing this element instead of this element, so if we'll be choosing this element, then the like result will be same as the previous one. And so with that we can say that we can, using k equals to 1 step, we can say that we can move like any element to the first of the array. Like we can form the array to be looking like 3 4 5 6 7 8 1 2. We can make the array to look like 6 7 8 and then 1 2 3 4 5. So this is the this is when we are selecting this step. And what will happen when we will be choosing this element? So let me show you. So suppose we selected this, so this will get like appended to the back of the string, right? And in the next step, actually I'm trying to show that using the k equal to 2 step, we can like swap any two adjacent characters. So here I am showing you how we can swap like 1 and 2. So this one can be moved to the back of the string using k equal to 1, because k equals to 2 step include choosing both first string and first character or second character. So yeah, and now like we can select all these characters one by one using k equal to 1 and move them at the back. So the new string that will be obtained after these steps will be 2 1 3 4 up to 8. So this is basically, we can see that we have kind of swapped these two like characters in the string. And since you using the k number 1 operation any number of times, we can like bring any character to the front of the array. Like we can bring characters 5 and 6 to start of the array, as we discussed previously. So we can also swap these two characters. And we all know that like if we are allowed to swap any two adjacent characters, we can sort like it is possible to sort the array. So in this case, in any case where k is greater than equal to 2, because k equal to 3, k equal to 4 will also include the k equal to 2 operations, we can sort the whole array. And so we can like return the answer, which will be the lexicographically lowest string that can be formed using the characters. So like for these cases when k is greater than equal to 2, the time complexity will be n log n, because we are using we are sorting n characters. And for k equal to 1, the time complexity is n squared. So the overall complexity of this idea is n squared. So we can code it. So let me erase all of this. Yeah. So first of all, we will be storing the size of the string. So we have got it in the n variable, and now we need to check whether the k is equal to 1 or not. So if k is equal to 1, then we can like consider all the n strings that can be formed. So I'll be using variable I to denote like from where we have to start the string, and it will go till n, and then we'll be selecting the n characters. First of all, I will be having a string called answer, which will like contain the lexicographically best like smallest answer. So first I will initialize it with s. I can have it I equal to 1, because I equal to 0 is already, this is a string. And I can also have a string temp to construct all the possible strings. So this I plus j mod n will represent the character of the temp string, and we can append this to make the temp string. Now we need to check where this temp is lexicographically smaller than this answer or not. So we can have a boolean. I can call it flag, and I will initially set it to true. So we will be iterating over the n characters of the both of the strings, and like just in case the answer jth character of the answer is smaller than the jth character of the temp, that means like this answer is smaller than them, then we can set the flag equal to false, and we can break. And just in case the answer of j is greater than temp of j, basically our temp string is less lexicographically smaller in this case, so we can directly break because this flag is set to true. And just in case both are equal, we will keep iterating, right? So if the flag is true, we can set the answer to temp. So after these two loops, we will have our answer in the answer answer variable, so we'll be returning it. And the other step will be when k is greater than equal to 2. So in that case, we can sort the string, because sorting will generate the lexicographically smallest string, and then we can return the answer. So yeah, so we can try to run it on the sample test cases. Yeah, it's working. Yeah, it got accepted. So thank you guys. See you tomorrow with a new like September lead coding challenge problem.